Hi everyone, welcome to the very last lesson and the last video of our whole year. So in this lesson, we're just going to solve various trig problems, and I wanted to introduce you to 3D problems. You will have one of these in your assignment. So let's get started. So here we go. Find the height of the cliff shown to the nearest meter. This is not the best diagram, but what I want you to picture here is this brown thing here is a cliff. So what we're trying to do is calculate the length of AB, which is the vertical, it's the height of the cliff. 90 degrees to this cliff, we can see we have water. And water ends, or this body of water ends at the shoreline here, which is this represented by this yellowish thing that's probably supposed to be sand. But anyway, CD represents a line along the shore of this beach. So the triangle DBC is actually flat and against the water, whereas AB and C is a vertical triangle that has length AB actually on the cliff. So imagine some engineers have taken these measurements, and what we want to do is figure out the height of the cliff without actually climbing the cliff. And we can do this. The first thing I want you to know is there is a common mistake here. And the common mistake is in these diagrams assuming, okay, this right triangle. And that is not, it is definitely not a right triangle. However, this is a right triangle, okay, because it's already there in the diagram. So ABC is a right triangle, but we can see that angle B is actually 180. Subtract the other two angles. It's 64 degrees. Okay, so let's put that in there. And now what we can do is we can figure out what we need to do to solve for AB. Now, my suggestion is to solve for AB, okay, what we need is to find CB. Okay, once we know CB, we can, it's the side that actually joins the two triangles in this question. So that's a big clue that that's the thing that we're going to try to find. Okay, so I can see that I can use the sine law here. Sine 47 degrees equals lowercase d sine 64 degrees over 143. So let's use cross multiplication here. Okay, and then I'm just going to compute the length of D, which is I'm showing as 217.5446. Does that make sense? It actually does not, because for some reason the length across from D is bigger than the length across from 64. So what did I do wrong here? I just made a calculation error. Okay, so 116.3599. That's better. That makes more sense. Okay, so now I know that D is 116 point, we'll just write 36 because it's too small, but now I can use that to solve my right triangle ABC. ABC. So I know that BC is 116.3599. I also know it's a right triangle, and I know that angle C is 39 degrees. So I can see that if I want to find AB, let's call that lowercase c. If I want to find lowercase c, I can just use tan. Tan 39 degrees equals opposite over adjacent. Okay. So guys, the question in your textbook is hopefully a little more clear, the image I mean. If you have any questions about it, you can ask me, but I think it's pretty clear. Okay, so C is 94.22. That is the height of the cliff. All right, let's look at the next one. John is 1.4 meters tall and is standing 12 meters away from a building. From his point of view, the bottom and the top of the building are separated by 55 degrees. Here's John. He's going to be weirdly lanky and much too tall proportionally for all this, but that's okay. We know that he's standing 12 meters away from a building. And from his point of view, we've got the top of the building and the bottom of the building, okay, separated by 55 degrees. How tall is the building to the nearest tenth of a meter? Well, what we're going to do is we can actually see, we want the height of this, we want X. So what we can do is figure out what we can look at this triangle. So we know that from here to here, we've got 1.4 meters. Okay, but we still have to figure out that the amount of the building that's above John. Okay, so what we can do is figure out what this angle is. Okay, and once we know what that angle is, we can use that information and use the sine law to figure out the rest of this question. Okay, let's look at the next question here. We've got John, he's 1.5 meters tall and standing 12 meters away from a building. From his point of view, the bottom and top of the building are separated by 55 degrees. How tall is the building to the nearest tenth of a meter? Okay, so this is obviously not to scale, but let's say this is John and he's 1.4 meters and he looks up at the building and down at a building at the bottom, and we know this is 55 degrees and this distance here is 12 meters. How do we solve this? Well, actually, what I think I want to do is try to set up the sine law if I can. And the way I'm going to do that is first by finding this value X. And I can do that easily because I know that this is a right triangle. Okay, so X is 12.01. Let's write that in here. 801. And let's look to see if we can figure out this angle, which I think we should be able to. If I wanted to figure out that angle, I get tan theta equals opposite over adjacent. So theta is tan inverse of opposite over adjacent. So I can see that theta is 6.6544 degrees. That's a really small angle. So if I know that this is 6.65 degrees or whatever, I can figure out this other angle here. So that other angle is 90, subtract that answer. So I know that that angle is 83.3456 degrees. Now, if I know that, I can figure out this top angle as well by subtracting 50. So I know that this angle is 46.6544. And now I have enough information to use the sine law. So I can say sine 46.6544 degrees divided by the length of the side that we found using Pythagorean theorem equals, and let's call this h, sine 55 degrees over h. And I can use cross multiplication to figure this out. And I get that the height is 13.6081. All right. Let's look at the next example. Looking up to the top of a distant mountain. Let's say this looks like a mountain, okay, guys? Looking to the top of a distant mountain, you measure an angle of elevation of 24 degrees. Now, compared to a mountain, your height is negligible. Okay, so we don't have to account for like 1.4 meters or whatever. So this is fine. We're gonna put your point on the ground. You then walk 35 meters closer to the mountain, and you get that your measurement is 32 degrees, which makes sense. It's going to be a bigger angle. How tall is this mountain? So what it's asking us to find is this height, okay, which is probably like inside the mountain somewhere. So what we're going to do is call that h, and we're going to call this x, so the distance from here to here. And we're going to use two different triangles, one with an angle of elevation of 24, and the other with an angle of elevation of 32. So these should both have the same height. I'm gonna make this one a bit bigger so it makes more sense. Okay, and so they both have h. The 24 has a base of x plus 35. This one has a base of x. If you remember, this is similar to one we did in class. We're going to use the tan ratio, opposite over adjacent. Tan 32 equals opposite over adjacent. And then something nice happens. We can isolate for h and then set these two things equal to each other. Okay, so we get x plus 35 tan 24 equals x tan 32. All right, x tan 24, and I'm going to bring the other x term over here, and then I'm going to bring the 35 tan 24 to the other side. Okay, I'm going to factor out an x. And then I'm going to isolate x by dividing both sides by tan 24 degrees minus tan 32 degrees. Okay, and now I'm going to put this in my calculator and see what I get. And I get that x equals 86.7454. Okay, let's try the next one. Oh, did we answer the question? We didn't actually. So I'm going to go back to the 32 x and h triangle, and I know that h equals x tan 32 degrees, so h is 86.7454 tan 32 degrees. So I get that h is 54.2 2046. There you go. So I have actually decided to take the content for example 4 out of the course this year, so we won't be talking about bearings or anything, but it's just one small part of the course, so you will need to know everything else. So let's just go right to example 5. Example 5 is deceivingly difficult. So let's go through this question. All right, you are standing in front of a building. Directly in front of you, at an angle of elevation of 65 degrees from your feet, Juliet is on a balcony. This is you. 9.3 meters above the ground. Romeo is standing directly to your right. So this actually becomes a 3D question. So 5 meters to your right is Romeo at a distance of 5 meters. At what angle must Juliet look down on Romeo? So her line of vision is going to look like this. Now, let's just remember what an angle of depression is. So if this is a horizontal, and if this is the vertical, okay, and this is Juliet, when she looks down, or anybody, when they look down, the angle of depression is actually this one, okay? So I said a common mistake was to think it's this one. But what we do know is that both of these angles have to equal 90. So we're going to use that here. But this is actually defined as the angle of depression. So when I look at this blue triangle, I can see that actually I only know one of the sides, which is 5 meters. And let's just mark out what angle it is that we're trying to find. So if this is Juliet's horizontal, we're actually looking for this angle, right? Now, this is going to be very hard to find unless we know the other angle, the one on the inside of this triangle. So actually, what we're going to try to do is we're going to link the base of the building to Romeo. Okay, and we need to find this pink length. And then what we can do is we can find this angle, alpha, and then subtract that from 90 to find the angle of depression. In other words, we're actually looking for this angle. So that angle is the same as Juliet's angle of depression. Okay, so hopefully I've laid that out in a non-confusing way. But what we do know is if we just isolate their triangle, oh boy. Okay, so if this is Juliet and this is Romeo, all we know is that this is 9.3 meters and we don't know anything else. So we're gonna have to use the blue triangle to figure out some dimensions of this thing here. So one of the ways we can do that actually is by looking at the triangle between you, Juliet, you and Juliet. Okay, so we know this is 65 degrees. We know that this is 9.3 meters. And now we have to decide which length here will be helpful to us. I actually think the most helpful I think the helpful side would actually be this one here. So I'm going to call it X. And we are going to relate the opposite and adjacent side through the tan ratio. Okay, and I'm going to figure out that X is 9.3 divided by tan 65, which is 4.3367. So we know that this distance here is 4.3367. So I'm actually going to write that up here. I'll do it in green. Okay, and then the next triangle that we are going to use that is helpful to us is the one between you, Romeo, and the bottom of the building, because we know that this is also a right triangle. This is 5 meters, and this is 4.3667 meters. So what we can do is we can figure out this value, I'm going to call it y, and we can recognize that this y is the same as the dimension here. Maybe I'll put this, let's call this b for bottom of the building. Okay, so using this triangle, we can figure out y, and actually we just need Pythagorean theorem. So I guess I can write it down. 4.3667 squared plus 5 squared equals y squared. Y equals 6.6187. All right, so now that we know these things, okay, we should be able to figure out the dimensions of this guy. Okay, let's move it over a bit. All right, so if this is 6.6187, the angle I'm actually trying to figure out is this one. So this is the final thing that we're looking for, which we know is the same as Juliet's angle of depression. So I can see that I'm going to use the tan ratio, 9.3. Okay, and we get theta equals tan inverse 9.3, 6.6187. And I can see that the angle is 54.5612. All right. There we go. All right, guys, so that's it. That's the end of the course. I hope you enjoyed trig, and I hope this helps you finish your assignment.